Hi everyone, this is Cynthia Snyder. In this lecture, I will talk about data normalization, which is a very critical process in the design of a relational database. Normalization is the process of reorganizing data in a database so that it meets two basic requirements. The first requirement is that redundancy of data is minimized. I said minimized and not completely eliminated because sometimes it's just not practical to completely remove data redundancies. So we will have some kind of data redundancies, but those redundancies are kept at a minimal level. The second requirement is to ensure that data dependencies are logical. That means that all related data items are stored together. Normalization is important for many reasons, but chiefly because it allows databases to take up as little disk space as possible and therefore resulting in increased performance of the database. Normalization is an important step in database design process because it removes redundancy, or I shouldn't say removes, but reduce redundancies, and it removes anomalies. Anomalies are database problems that arise from the way the relationship between tables are defined. There are three types of anomalies: insertion anomalies, update anomalies, and deletion anomalies. And insertion anomalies occurs when you can't enter certain information. For example, let's assume that this file is the only place where data is kept at a clinic, and basically everything is kept on these files. So let's say a new doctor just got hired at this clinic. Suppose the doctor is undergoing employee orientation for the first few weeks of her or his employment, and is not scheduled to see any patients. So how do we enter these doctors' information? Notice here that the only way physicians are entered is when there is a patient information in this data sheet. So if a doctor does not have any patient scheduled to see him or her, then that information about that doctor cannot be entered in the system. So someone might say, well, let's just create a dummy data so that a new physician could be entered in the system. But it's not really, I suppose you could do that, but it's not really a good idea to put meaningless data, and doing so can compromise the integrity of your data in your database because of those meaningless data that you enter. Update anomalies occur when the same data is stored in more than one place. So if data needs to be updated or changed, we'll have to find every single instance of that data and change every single one of them to make sure that the data is consistent. So in this example here, let's say Eric Clapton has a new phone number. So we have Eric Clapton right here, and so here's Eric Clapton, and let's say his phone number needs to be changed. So his phone number is right here, and let's say this Eric Clapton guy has been with the clinic for 10 years and have unfortunate, terrible many chronic conditions that required him to be seen by various doctors quite frequently. So there may be hundreds of records for Eric Clapton that needs to be updated. Now, I suppose, if you have only one record like this, it's quite easy to change the information to update it. But if you have hundreds and hundreds of records that need to be updated, it could be very, very cumbersome. And imagine if one of those records do not get updated, or let's say another one was updated incorrectly. And as you know, when you type in data, it's quite easy to make a data entry error. So one records did not get updated, the remainder of the records get updated, or maybe one of them got updated incorrectly. So now Eric Clapton has 3 different phone numbers. So what is the problem? Well, the problem is, let's say a receptionist need to call Eric Clapton about his appointment. Maybe they need to change his appointment. So which number to call? And you could say that she could use the most recent data that was entered in the system to make sure that it's the most recent phone number. But what if the last record is the one that didn't get updated, or the one that got updated incorrectly? Deletion anomalies occur when a deletion of certain data would cause a deletion of other data and therefore affect the database integrity. So in this example here, suppose the patient Ella Fitzgerald, and let's say she wants to cancel her appointment. Technically, we only have to delete the appointment time and the appointment date, or vice versa. But because how the data storage is structured, we can't delete the appointment date and time without deleting patient and physician information. So when we delete appointment date, the appointment for Ella Fitzgerald, not only do we delete appointment date and appointment time, but we also delete everything in that line. So that is the problem with deletion anomalies. So how do we take care of all these data anomalies? We do that through the process called normalizations. I have explained to you earlier about what normalization is, and now I want to talk about the steps in performing normalization. When we perform the normalization process, we are actually going to evaluate the structure of the table, and we want to make sure that the table is evaluated based on specific criteria, and those criteria are called first normal form, second normal form, and third normal form. In a relational database theory, there are actually some other normal forms, higher normal forms, but typically it is good enough to stop at third normal form. So for this lecture, I am going to discuss the first, second, and third normal forms only. The table is in first normal form when all the key attributes are defined. There are no repeating groups in the table, and also a table is in first normal form when all remaining attributes are dependent on the primary key. So let's take a look at an example or how we can perform normalization process in your database project. So this is a preliminary entities and attributes that we have identified for our project. Notice here that we have instructor in the class entity. If we go to the original registration data, we will see that instructors' names are entered as the full name. So here is the column for course instructor. So you see Janet Jones, Laura Buckingham, Mark Anthony, Nikki Mintz, and so on. So this includes the first name and last name of the instructor. So what does this mean? Remember that the first normal form says that each column stores one value only. So here in this column, we have two values stored here, which is the first name and the last name. So just by looking at this data, you may be asking, what is the big deal? Well, in this example, let's say we want to list instructor's name in alphabetical order by last name. So because it was entered as first name first, it would be impossible to sort the course instructor's name by last name in alphabetical order. So we need to break that. So if we go back to our thing here, we will have, maybe we put instructor first name, and then I'm going to insert, maybe we'll put instructor last name. Okay, so that meets the requirements of first normal form in that we store one value in each column. Remember, these attributes are going to be columns when they are implemented in the database. So if you look at employee name, we also have similar issue, which is, the first name and last name are entered in the same column. Okay, so we take care of first normal form. So as of right now, we can say that our database in first normal form. After we have achieved first normal form, we need to make our table to be in second normal form. For a table to be in second normal form, it must satisfy the requirement for first normal form, and we know that what we have is already in first normal form because we did that earlier. Second normal form removes functional dependencies. One way to think of functional dependencies is as separate groups or themes within an entity. An entity should only be about one thing. All members or attributes should be dependent on the key, not on each other. So what does that mean? Let's take a look at our example, our data. So in this example, if you look at employee department, course, and classes. In department, everything, department and department ID, so they all belong together. They're describing the same thing. The same thing with course. So we have the course title, the course fee, the course date. These are all describing the same thing, which is describing the course. But if you look at class, we have begin date, end date, instructor, first name and last name, and room. In here, in a class, these two should belong in class, but instructor name and instructor last name, these are different objects. So we need to break this out into a separate table, a separate entity group. So what we will have is instructor, and we will have instructor ID, and then we will move these down here, and we will move these up like that. And how do we connect this is by connecting them with a foreign key. And so in the class, instead of having instructor name and instructor last name repeated in different rows, we are going to have instructor ID as a foreign key. So basically, this instructor ID will refer that data to the instructor first name and instructor last name. Okay, we should also look at our employee table. Here we have departments, but you know that to connect um, two tables, we need to connect a primary key from one table and a foreign key in another table. So instead of department here, we really want to connect it with the foreign, use the department ID as foreign key in employee table. So again, department ID comes from department table, in which department ID is the primary key. So when we use it in a second table, that will become a foreign key. And we will show the relationship between these different tables from the by creating a relationship between the primary key and the foreign key. So we want to draw a line to show that. So that way we keep track of all the um, relationship that we created. Another thing that we want to look at also is that earlier we talked about class having a relationship with course, but there is nothing in the class or course that would connect them. So we want to create a foreign key in the class entity to connect it with course. So the rule that you must follow is that the primary key is always placed in the many side of relationship. And if we go look at the entity relationship diagram that I presented in another lecture, the many side of relationship is the class. That is the course and class relationship. So we will place course ID in the class table and use that as foreign key. So again, the foreign key always resides in the many side of relationship. And again, the same goes with employee and department. So employee is the many side of relationship. So that's where the foreign key is placed. And we also draw a line between course ID and a course ID in course and course ID foreign key in class. Now we want to move on with the next step, which is to make sure that your tables are in third normal form. For a table to be in third normal form, it has to be in second normal form. And third normal form is about removing transitive dependency. Transitive dependencies describes an attribute that depends on another attribute. I should also mention here that room really is not dependent on the class ID in class entity, so technically it should be removed. However, I decided to keep this in here because it is only the value that is going to be stored in this particular column is very small. So as you can see, if you go back to the original registration data, it's only 4 characters that we need, or maybe 5 characters to keep that data. So I am going to keep that in this week. If we want to go strictly by the normalization process, of course it will have to have its own table, because room is definitely not, it doesn't describe a class. So but if you're going to have room, you're basically going to have room ID 1 and then whatever that room number is. So it takes more from a maintenance perspective to maintain this database by creating so many different tables. So it is okay sometimes to denormalize your data in exchange with less complicated database. So for that reason, this room is going to be left in the class table. Okay, so I wanted to talk about the special relationship that exists between employee and class. Earlier in my lecture, I talked about employee and class having many-to-many relationship. In your IRD, in the ERD, you see that relationship with the specific cardinality to show that many-to-many relationship. Unfortunately, um, while it is okay to have many-to-many relationship in your modeling, it is not fully implemented in your physical design, which is the actual creation of the database. So if you have many-to-many relationship in your model, you will have to change that relationship, break it up into two one-to-many relationships. So basically, many-to-many relationship, you break it down into two one-to-many relationship. So I'll show you how to do this. As you can see here, I have rearranged my table so to make it a little bit clearer, hopefully. And to break a many-to-many relationship between employee and class, I have created a bridge table. This bridge table basically is a mechanism that would allow you to create two separate one-to-many relationships. So this enrollment table basically will store information or data about enrollment of employees to class, or employees enrollment in class. So in here, for the enrollment, you will have enrollment ID. Obviously, for each table you have to have that primary key. So this will become the primary key for this table. And then you will have employee ID to make a reference to the employee table, and you will have class ID to make a reference to the class table. However, the employee ID is going to be a foreign key here because it is the primary key in employee table. So you can't have them both as primary key in both places. So the same goes with class ID. So here it is going to be foreign key. And remember, I said that the foreign key should be placed in the many side of relationship. So if I let's think about this relationship. One employee will have many enrollments, right? Because an employee can take many classes, which means that they will have many enrollment data. And in each enrollment data is only related to one employee, because you can't have one enrollment data for many people. You will have, in this case, we are not doing the relationship yet. We're not defining that relationship yet, but we are making sure that we have the primary key and foreign key and in the tables that we are creating the relationship for. So again, I am going to make sure that my employee ID goes with employee ID here, and that my class ID goes with class ID here. Okay, it's kind of crazy looking, but I want you to see how the primary key must match a foreign key in another table in order for a relationship to exist. Here is what your final ERD should look like. So you will have 6 entities. You have employee, department, class, instructor, course, and then of course the bridge entity or bridge table that I created in order to take care of the many-to-many relationship that existed between employee and class. So by creating this bridge table, I break the many-to-many relationship into 2 separate one-to-many relationships. So you have employee to enrollment as one-to-many relationship, and then enrollment to class as the other one-to-many relationship. So be sure to use this ERD along with the attributes that I listed here to implement in the creation of your database.